Okay, so in this video, I'm going to explain to you guys how to program your autonomous. Autonomous is really important because it helps you boost your score during your skills runs. So in your skills run, you have your driving portion, but you also have your programming portion where you plan a route and you do that based in programming. So I've already covered before on how to write your code for the driver portion, and I don't have this necessarily on here only because I already taught it to all of you guys and you guys should be good to go on that. So I'm just going to cover the very just the programming portion today. So when we're doing autonomous, some of you guys might be asking, what does autonomous mean? Autonomous means the robot just moves by itself. You're not giving it any inputs on what to do. It kind of just goes on its own. So, what's the first step in programming? The first step in programming is always determine what you want to do, okay? So here I have a picture of vexCode, right? And I'm just gonna annotate some stuff. Let's say my robot sits right here, right? This is my robot. Maybe I want to move forwards first, and then I want to turn, and then I move in underneath here. I lift up my arm, and then I put my, it knocks these discs over. I put my arm down, I move backwards, then I'm gonna turn 180 degrees, and then I move forwards into here, and then I lift up my arm, I put my arm back down, it knocks these discs over, and that's my autonomous run, right? So we want to write that out in words. So I'm going to write that out real quick. So 1, move forwards, 2, turn right 90 degrees, 3, move forwards into right side loop disk holder 4, I can type, lift arm up to discs 5, put arm down 6, move backwards across field 7, turn 180 degrees. We're gonna go right. 8, move forwards into left side, glue disk holder, and then 9, lift arm to knock discs. Perfect. And this is an overall pretty detailed plan, and this will help us exponentially when we're actually programming your code, okay? So keep this in mind. This is great to have in your design notebook. Maybe you go and you title it like coding plan, and you have this very detailed plan, because trust me, the moment you have a detailed plan, programming will become 10 times easier to do because you have a clear goal in mind. So now that we've gotten through that, I want to go through our second thing that we have to do, our touch LED. So since most of you have your driver control, you have your driver control, like when axis A is changed, set left drive velocity to, you have your driving stuff there. We want to have it in the same program, which brings me to the next thing. How are you supposed to start your program without touching your controller? And that's where touch LED comes in. In a lot of videos by Vex, they demonstrate this by saying, like they tap the light, the little LED, and then it starts their autonomous program. So I'm just going to initialize in our motors list a touch LED that's called start auton. Why? Because the moment we click it, we want it to start our autonomous. So in our events, I'm just going to go here. If we remember what our events do, our events like detect stuff that happens. It detects like, oh, the controller button was pressed, it was released, the axes on the controllers changed, yada yada. But it can also detect when when the touch LED was pressed. And if you remember, our touch LED is called start auton. It's nicely there selected because it's the only one we have. Now, next thing we have on our list is moving. So how are we able to move? So when we move, what I suggest, we have those three kind of moving blocks right here that are like control most of our motion, right? This first one will indefinitely move our motor, right? Which is great for when you're like running the code during driver for our controls, because we don't know how long we're moving it forward. This one, this next function, it's for 90 degrees. So let's say this is your wheel, and this is position 0. To move 90 degrees, it's going to move to this spot. Now, you're saying, well, this is position 90. Yes, but let's say it's here at this awkward spot. It's still going to move 90 degrees to create like that 90 degrees, okay? And what you'll understand is that like for this one, it's moved to position 90 degrees. So this one is saying regardless of wherever the motor position is at, let's say it's a position here, if you tell it to move to 90 degrees, it will move to this position here. If it's here, it will move to this position here. So I don't necessarily suggest that for this purpose that we're doing right now. So what I suggest right now is we go for this block right here. Okay? So when we have our block of code, it moves our left drive forward for 90 degrees, right? But if we think about it, if this is our bot, and we've got our wheels, and wheels, and wheels, and wheels, if we move just this side forward, then it's going to start turning, right? It's going to start turning awkwardly. So we want this side to move forwards too, right? So that's what we have to do. This is our little robot diagram for now. So we can add another block that says right drive, move forward for 90 degrees. But our issue with that, it's going to move this, wait for this one to finish moving, and then move this side, right? We don't want that. We want it to move nice and evenly together kind of forwards so that we're able to successfully kind of have that nice smooth motion. And if we notice this little arrow here, what's really nice is in don't wait. It's saying that we want to move 90 degrees, but don't wait for this block of code to finish before starting the next block of code. So what it's going to do, it's going to allow us to run this side and this side at the same time, right? Which is exactly what we want to be able to do right now. So that's how we're able to get it to move together. Now, the next thing is like, oh, let's say I want to move my arm up and down kind of thing, right? Then what we have to do is just set it to like our arm. We want to spin, I don't know, maybe 300 degrees. And this is just something that you guys will have to test and see how it works out for you guys. It spins forward for 300 degrees. Now, over time, you'll see like move, 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 move. You'll be repetitive doing this, right? It gets tedious over time, right? So we're going to scrap, not all of it, we're going to scrap this part. It's going to get tiring. And for reference, if you're ever looking for how to turn, if you remember, the way we turn if we want to turn right, we put our right in reverse, and then this forward, because what will happen is this starts spinning this way, this starts spinning that way, and this starts spinning that way. And if we want to spin left, put our left in reverse. And we'll put our right forwards, right? It's just like same thing. This spins that way, that spins this way, so we're turning like left together. And if you want to go backwards, kind of same concept. You put both in reverse, kind of thing. Okay, continuing on. Now, this is going to get really repetitive really quickly. And if you've ever noticed, there's this pink section called My Blocks, and it says make a block, which is really different than all of these other kind of blocks that we have before. But this will come into handy. This is called a function. What a function is basically a block of code that is defined that runs other blocks of code within it. So let's test it out. We're going to call this drive, right? And we're going to add an input. Let's say this is degrees, and you might be a little lost right now, but don't worry, it'll make sense in a little. So let's say we want, this looks like now like another one of these variables, like looks kind of like this one, but a lot more simplified, right? We only have one value to worry about. Now, this is where we state what this block of code here is going to do permanently, right? Every time that we call, per se, this block of code, like in our main segment here, it's going to do whatever it says here. But right now, there's nothing in this section. So we have to define it, like what it says right here. We have to define what this block of code here is going to do, right? So maybe it says drive, right? So maybe we want to drive it. But right now, it's saying to drive forward for 90 degrees, meaning every time we call our block, it's going to move our entire thing forward, but it's only going to turn the wheels 90 degrees forwards, which isn't a lot for reference. So maybe we want to be able to change this value while only still having to use this one block of code, right? So what's really cool is this little value pulls out, and you can stick it in there. What's really nice about block code is that our code is able to, when we are putting values in like other blocks, like we put it here or we put it here, the shapes like help us identify what kind of value goes in it. And I'm not going to go too in depth into that today because it gets a little complicated kind of fast. But this allows us to say that we want to, when we call it over here, allows us to say, I want to move forward 300 degrees. This value is the same as this value over here. So it'll say, move forward for 300 degrees and don't wait. And if you remember when we were programming our controller, even though it said to move when we spun the drive forward, it would still go backwards because the value that our axes returned, when we went forwards, it returned a positive value, and when we went backwards, it returned a negative value. And vexCode was smart enough to know that the negative value means to go in the other direction, which is perfect for us. So we can put a little note for us. This is a comment, and it's not going to do anything to our code. It's just kind of there for our reference. So we say positive forwards, negative backwards. And now every time we run our code, it's going to go through this. It's going to say, oh, we need to go check over here and see what is it telling us to do. It's going to put the value 300 here, and it's going to replace this value with 300. So it's going to spin the spin your base 300 degrees. Now, we can do the exact same thing, but we can do it so that it turns. So let's define another block, which is great, turn degrees, and we're just going to copy paste this block, right? Because, great, it's easy. And we're going to set 1 to reverse. Why? So that we're able to actually turn, because remember, if we want to turn, one has to go in the opposite direction as another. Now, we have to make sure these values are like this degree. So we're just going to remove those real quick and put those in. Now, if you remember, since our left drive is going reverse, it means that we're turning left when our value is positive. So I'm just going to say that our positive means that we're turning left, negative is right. So then, over time, we're going to be able to say, if we look back to our plans, we can say, oh, I want to move forwards, right? And we can put these blocks of code kind of off to the side, because we need to remember that that's why we have these other separate blocks of code. Our first step was move forwards, perfect. Then want to turn right 90 degrees. So we want to turn, but if we remember, we have our little note here. We need a negative value for that. I'm just going to take a wild guess and say that it takes 350 degrees for my code, for my drive to turn 90 degrees. And that takes me to the last topic of this video, trial and error. Programming is all about trial and error. You could run it 50 times before you even get it to do what you want it to do. So you just have to run, I would suggest you run 1 block of code at a time. You run this, is it the distance that you want? Yes. Then add another block of code. Then add another block of code. Like, let's say now I want to, that's not next on my step. Next in my step would be move forwards again. So we go move forwards, and let's say I want to move less. Let's say 120 degrees is left for me. And I'm not saying these values are necessarily correct, but this is just an example. Then you have lift our arm up to knock discs. Okay, and now I have to spin my arm forward for, I don't know, 100 degrees. And then we want to spin our arm reverse for 100 degrees maybe, right? Because that was our next step, to go put arm down, just this block right here. Then move backwards across field. Okay, well, we have our block here to do that. But if we remember, if we want to go backwards, we have to put a negative value. That's where we have to go negative, I don't know, 500, because this distance from here to here is quite long. So I'm just going for a larger value now. Then we did this step, and then we turn 180 degrees right. Turn, remember, right is negative. And if this was 90 degrees, now we want to move farther. Maybe that's the value I need to put in. I cannot emphasize enough how much trial and error programming is. So remember, if you're just trying to figure out what's not working out, do 1 block of code at a time until it works. And then add your next block of code, because then maybe it will start working. That's the best advice I can give you guys for how to program autonomous in block code for vexCode IQ. If you have any questions, do not hesitate to reach out to me. I will try to be as available as possible for any questions. And I hope you guys have a good run at your tournament this weekend.